There's 8 multiple choice that has 6, and so 2 free response that has 1. So can I give you an idea without taking the whole period? So what is the homework you need to say?
Number 104 through
104 through 106,
And
okay?
I think 97B.
let me look at it.
Yes, that as well.
Okay, so we're looking at 104 through 106, I heard 85, and then somebody said something in between.
97B.
Anything else? Okay, let's start with 85. To work 85, I was hoping somebody would ask about this because there's one I think similar on either the quiz or the test. But this was 85 and it said go back to 83. So here's 83. So maybe you want to look at your 83 and make sure you got this correct information. This is saying that a customer buys either regular, mid-range, or premium gas, and that was given to me. And for the folks that buy regular, 28% use credit cards, the others, do not, so that's 72%. 34 do pay credit card from the mid, 66 no. If you buy premium gas, 42% use a credit card, 58% do not. Okay, so that's how you would set the table up on 83. And 83 also asks about the probability that you would use a credit card. What's the probability that a person would use a credit card? And the answer was 29.5% or 0.295. You needed all of that to do 85. Because 85 asks you refer to exercise 83. Given that the customer paid with a credit card, find the probability that she bought premium gas. So you would write this probability statement this way. Given that, whatever has already occurred, which in this case is given that they paid with a credit card. So that's how you set it up. The thing that's already occurred is what comes after the given that. Sometimes they'll be nice and just say given that. Okay, and according to your formula sheet, anytime you have a conditional probability, the formula is this. You're going to take the and of both and put it over the probability of the given that. That's how that's going to work every time. So are we okay? And that's on the formula sheet, so you can use your formula sheet. But when it's a conditional, you take these and find the and or the intersection, and then on the bottom you just are finding the probability of whatever was here. That's it. That's just the formula. I'm just plugging into the formula. So first thing I've got to do is find the probability of premium and credit card. Well, that's not too bad. You just go to your tree chart, your tree diagram. Here's premium. Here's credit card. So that numerator is going to be 0.042 because that's the probability of premium and credit card. Now, the probability of a credit card, we found that in the previous problem. It was 0.295. The way I got it was finding all the options that used credit cards, and I got this number by multiplying, and I got the 0.295 by adding. You multiply this way, you add this way, so the denominator is going to be 0.295. And when you crunch those two numbers, yes.
Is there like a distinct way of knowing if you're going to use a two-way table or whatever, or a tree? Or
I tell you, here's my clue for the tree. If they give you somebody doing a couple things, most of the time you're going to do a tree diagram. And so in this case, did the person do a couple things? Yes. They bought a certain type of gas and they paid with a credit card or not paid with a credit card. That's when I would use a tree diagram. Sometimes if it's real simple, a Venn diagram will work if there's only a couple things going on. But if you got some folks that are doing a couple different things, 2 or 3 different things, tree diagram's where you want to go. There's not really a hard and fast rule when you use it though.
What do you count off if we don't use the preferred diagram?
You'll have to show your work, so I think it's going to be obvious to you that your free response today will require a tree diagram, if that helps, since we're getting our feet wet with this. Your free response, you're going to need I can't think of a way to do it without it right now. But as long as you show some work, if you want to go a different route once you get an understanding of probability, I'm okay with that. But for right now, I think this is the way to go. Let's look at 104 and 106, but before I do that, these are the last 3 homework problems. Is there anything else? Everything else was okay? I'm telling you, this is big. If you're okay with conditional, that's a big thing. Having a good understanding of when independence is important and what that does to your multiplication rules, and when mutually exclusive is important and what that does to your addition rule. Okay, let's go to look at 104 now. 104 says an athlete is suspected of using steroids. Test A has a probability of 0.9 of being positive. Test B has a probability of 0.8 of being positive if in fact steroids have been used. What is the probability that neither test is positive if steroids have been used? And that first word in there has independent in it, so it tells you that the tests are independent of each other. So if they're independent, then if you want to know the probability of A and B, it's super easy. It's the probability of A times the probability of B. They're independent of each other. That's all you have to do. You don't have to do anything else. You don't have to subtract out to worry about double counting something double. So on that first one, we want to know specifically about the probability that neither test is positive. So if the probability is 0.9 that the test is positive, the probability that it's not positive is 0.1. The probability that this one's not positive is 0.2. And I think all they wanted you to do there is to use that special case of the multiplication rule when they're independent, and all you have to do is multiply. It doesn't have that little bit at the end.
So mutually exclusive is the only time you can subtract out?
I think when you're looking at and statements, you're thinking about independence. And if they're independent, you use this really simple formula. When you're talking about the or the adding, it's when you look at mutually exclusive, and that if it's mutually exclusive, that makes it real simple. You just add.
So when you use the subtracting out again?
Do what?
When you use like probability of A times probability of B minus the probability of A and B.
When it's not independent.
Okay.
When it is independent, you can just go here because there's not an intersection. Alright, hopefully you marked up your formula sheets that day we looked at them because of course I'm going to encourage you to use your formula sheet. Let's look at 105. I hate answers that the real answer is not given because I just don't like those. But on 105, we're talking about people that got food poisoning. And so they examined 50 people from a conference that actually had the food poison. And then they did a random sample of 200 people attending the conference who didn't get food poisoning. The detectives found that 40% of those with food poisoning went to a cocktail party. So 40% of our sick folks with food poisoning went to a party. While only 10% of the people in the random sample attended the same party. Which of the following statements is appropriate for describing the 40% of people who went to the party? We want to describe the 40% of the people who went to the party. And the correct way to describe it, let me just show you the correct way to describe it, and then we'll talk about why the other ways. All I wanted was for you to do this part. And so the correct way to describe it is the probability of, given that you got food poisoning, you went to the party, or you went to the party, given that food poisoning is already a thing that happened. This is kind of a finer point on understanding the probability statements. I thought this one was kind of tough. Did anybody want to go with this one? I thought that was probably the one that most people chose. This one says something just a little bit different. This one says that 40% of the folks that attended the party got food poisoning. That's incorrect, because 40% of the people that attended the party didn't get food poisoning. Among the ones that got food poisoning, 40%. So that's it's kind of a fine point there, but that's why that's A. Do we need to look at 106? Is that one we want to look at? 106. Suppose a loaded die has a probability model. 30% chance of rolling a 1, 10% chance of a 2, 10% chance of a 3, 10% of 4, 10% of 5, and 30% of 6. So it's loaded to land on a 1 or a 6. If the die is thrown and the top face shows an odd, what is the probability that the die shows a 1? So let's get our probability statement down. We're already given that it's odd. That's a thing that's happened. So that's limiting us. But given that it's odd, what's the probability that it shows a 1? So you have to go to your table and say, okay, what's my sample space? We're only looking at the ones that are odd. So if you're looking at that table, how can you get an odd? You can get an odd by rolling a 1, 3, or 5. And if you put those probabilities together, that gives you 50% for your sample space. Because once you have that given that, you might as well cover up the evens. That's not a thing we're looking at this time, because this is a condition that's already occurred. Then you just want to know what's given that, how can you get a 1 odd, a 1 and odd, 0.3, and then if you do the math, that gives you the correct answer of D. And the formula was the probability of a 1 and odd over the probability of just plain. If you wanted to look at it formula-wise. Anything else on the homework that you'd like to say? Or any other questions? If you want to get out your formula sheet,